Hello student, good morning. Today we are going to discuss the general characteristics of the S block element, that is group 1 alkali metal student. So the very first point in the general characteristic, they are the electropositive. Okay, whatever the metals are there like lithium, sodium, potassium, rubidium, cesium and francium. They are the electropositive student. That is, they all is having the positive one positive character. Silvery white, they all are what student? This is the silvery white metal, right? White. And they are also, that is, soft. Okay, they are soft and light metal. Soft and light metal. So that you keep in mind student, they are the electropositive, silvery white, soft and light metal. Okay, they readily lose electron to give monovalent ion. Okay, they are not found in the free state in the nature. So if you talk about lithium, sodium, potassium, rubidium, cesium, francium, so they all lose one electron student, lose one electron. And what they are forming? Lithium plus sodium plus potassium plus rubidium plus cesium plus and francium plus. That is, they are what is known as a student monovalent, that is M plus ions. This is M plus ion. Now students, next point, if you are saying they are not found in the free state in the nature, because they are very reactive student, so they are not found in the free state in nature. Okay, next one is atomic and ionic radii student. The alkali metal atoms have the largest size in their respective period of the periodic table. They are having the largest size student. Okay, so in the period, if you talk about a student, they are having the, if it is talk about, so lithium, sodium, potassium, rubidium, cesium, or no, sorry, in the period, if you talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so here is radii decreasing student. Radii decreasing means what is? This is the largest size. They are having the largest size. Okay, so they are, that is what they are saying. The alkali metals atoms have the largest size in their respective period of the periodic table. Right, student? Next point. The monovalent ion are the smaller than the parent atom. That's very easy. When the loose electron attraction force between nucleus and electron increases, so that is Z effective increases, so that the size of the monovalent ions are smaller than the parent atom. So order of atomic radii is lithium, then sodium, potassium, rubidium. So highest is cesium because more number of cell, potassium, sodium, lithium. Order of ionic radii will be the same student. You can find out that is cesium is largest than rubidium. It means down the group radii, what is happening student? Radii increases. Why radii increases, dear student? Because number of cell increases. Number of cell increases. So as the number of cell increases on moving down the group, so that what will happening student? What will happening? So radii will increase. So order of radii will be what student? That is, you write, that is cesium is highest, then rubidium, then then potassium, then sodium, then lithium. If iron is there student, that is same order, lithium plus highest, then Rb plus, then K plus, then Na plus, and then Li plus. This is the order of ionic radii, and order of that is atomic radii students. So this is what the atomic radii. Let us have ionization enthalpy student. So the order of ionization potentials is lithium is highest, the potassium, sodium, potassium, rubidium, cesium. The second, ionization enthalpy are very high. They cannot form divalent ion. So what they are saying is student, lithium, sodium, potassium, rubidium, cesium. These are, so down the group students. Down the group, what is student? Down the group, what is happening? Size increase. Size increase. Size increase means what is happening? Force of attraction decrease. Force of attraction student decrease. And if force of attraction decreases student, less energy required. Okay, less energy required to remove the outermost electron. To remove outermost electron, outermost electron. Okay, so that is what we can write. So low ionization energy, right student? So this is what the ionization enthalpy. Next point is hydration enthalpy, student. So let us look over the hydration enthalpy, student. So the size of alkali metal ions in aqueous solution is size of alkali metal ions in aqueous solution is lithium is high, then sodium, potassium, rubidium, and cesium. You know, size of alkali metal ion in aqueous solution. So most solubility is lithium, then sodium, then potassium, and then rubidium, and then cesium. Why, student? Is smaller the size, you know, and you know so here is lithium is highest size in aqueous solution. Why? Because you find next problem is to how hydration enthalpy. This is so lithium will be surrounded by so many water molecules, student. So many water molecules. So its size will be very high because it is very much hydrated, student. Lithium plus ion. So it is its solubility. What they are saying, so its size will be very high, student. Then it will be that is sodium, then potassium, then rubidium, and then finally cesium, right? So that you have to keep in mind the order of hydration. So smaller the size, high the hydration enthalpy. So ionic mobility and conductance aqueous solution is cesium, rubidium, potassium, sodium. Because ionic mobility, you see, student, it is very large size in the aqueous solution. It will not, it will combine with so many water molecule. But here if you talk about water molecule, it is very less water molecule, student, 4. And here is the only three water molecule, student. And here is the two water molecule. Okay, here is one water molecule. So this is very big size, student, because the water molecule are the six. Okay, so six water molecules. So that is movability is no, here to here. So movability is decreasing, student. Here the movement decreasing. It is the least movement, and here is the most movement. Okay, in aqueous solution, the movement of the this will, because smaller size, greater movement, student. Next, the Li has a maximum degree of hydration, so lithium salts are mostly hydrated. Okay, so that is what they are talking about. Density. These elements have low density, which increases down the group from the lithium to cesium due to their large size. Potassium is lighter than sodium because potassium contains vacant D cell and ineffective packing in crystal. So what the point is, student, is that potassium is lighter than sodium because potassium contains vacant D subcell in and effective packing in the crystal lattice. And that is what the answers. Order of density: cesium highest density, then rubidium, sodium, potassium, and lithium. Right, student? So disorder is there. Melting point, order of melting point and boiling point: lithium will be highest, then sodium, potassium, rubidium, and cesium. Okay. Why this is the order of melting point? Because it is having the lithium is having hmm, stronger lattice, student. Okay, stronger latting. No, the lattice is strong lattice, student. That is because of lattice compared to compact lattice. You can see compact structure, its melting and boiling point is high compared to cesium. So next one is flame test. Alkali metal can be detected from the flame test and determined by flame photography, photometry. Lithium is crimson red, sodium is yellow, potassium is violet, rubidium is red violet, and cesium is blue color. So this is photoelectric effect. These elements, when irradiated with the light energy absorbed may be sufficient to make an atom lose electrons. This property makes the cesium and potassium usable as electrodes in the photoelectric cell. Okay, these elements, when irradiated with light, the light energy absorbed may be sufficient to make an atom lose electron. This property makes cesium and potassium useful as electrodes in the photoelectric cell. So that is what, because they have low ionization enthalpy, they are being used as a in the photoelectric cell. Thank you so much for watching, dear students.